Okay, be sure and break out your Google Sheet to gather your data for this lab. There's the mass of magnesium. And now we'll wrap the magnesium up, folding it, wrapping it in copper wire so that we can use it to suspend in the top of the gas collecting tube. Okay, it can be a little tedious, a little bit like making a yarn ball. You can see that I've got the wire completely surrounding, but in an open format. Now be sure and take the temperature of the water. We'll assume the air is the same temperature. Next we'll add the 3 molar acid that you calculated in the pre-lab. The bottle may say 6. I think it's been a bottle that's been repurposed. And a little bit of red food coloring has been added so that we can see the acid as the reaction takes place. So it'll be a little more obvious since it's a different color than the water. You calculated a particular amount in the pre-lab. You can see I've used a little bit extra. Doesn't really matter since the acid is excess during this reaction anyway. Next I'll add water to fill it all the way up to the top so that we will be able to measure the volume of gas that forms. When the water is in the tube, we can of course see the bubbles forming and know when the gas collecting tube contains a particular amount of gas. Now the cage with magnesium is inserted and the stopper, which has a hole in it, is twisted gently and finger over the hole, tipped upside down and placed into the beaker. I think if you look closely you should be able to see the acid as it drifts down through the water to make its way towards the magnesium at the bottom. Again, that acid slowly making its way down towards the magnesium at the bottom. You can just see it wiggling the solution there, and it looks like the reaction is just starting, some bubbles just starting to form. Now the reaction, which took about 5 minutes, is in time-lapse mode, and so you'll see it happen very quickly here. And when the reaction stops, you can see that the water is still above the surface of the water in the beaker, so we'll transfer to a deeper container. Oops, not deep enough. Let's move into the very large graduated cylinder, and we'll make the level of water in gas tube even with the level of water inside the graduated cylinder. Look carefully, do your best to record a measurement for the gas that is present above the water and record that to the right number of significant figures in your Google form. Next I'll show the air pressure from my phone. Do not record the temperature that you see. You got it earlier, as that is the outside temperature. Let's take a close look at the reaction and pay attention to the procedure item number I and post-lab question number 2 as you're watching this close-up view of the reaction. If you look carefully, I think you can see some of the very tiny gas bubbles do escape through the hole at the bottom as they're pushed out with the water that is being pushed out of the tube by the formation of the gas that is rising to the top. And the reaction ends very abruptly when all of the magnesium is gone. And take a close look. I think you can see there are some bubbles still lingering, and I'll show in the procedure what can be done to help with this potential source of error. We'll take a look at why we used copper wire in this lab, and not a cheaper wire, perhaps iron. So you'll see I've set up 2 beakers of the acid and put copper wire in on the right, and here's iron wire on the left. Certainly you can see the difference between the two. But you might be asking yourself, why do we even need the wire cage? Let's take a look at what can happen if we don't use any kind of a cage to hold the magnesium. Okay, putting the piece of magnesium in the top of the eudiometer. Uh-oh, it's sinking down. Better hurry up. Don't want it to fall all the way down and react. Turn it upright. You can see the magnesium comes back to the bottom. Whew, no reaction started yet. So we averted that possible disaster. So take a look and watch. The issues aren't over yet. There may be some more problems that result from the magnesium not being held in place. So the reaction continues along. Everything seems to be going okay. I do wonder if having the piece of magnesium very close to the bottom of the stopper makes it easier for some of those tiny bubbles to escape, rather than being held up a little higher in the tube. But as the reaction really gets going, some of the bubbles stick to the magnesium temporarily and may change its buoyancy. And wait for it. It's coming. Watch closely. Bubbles escaping. Uh-oh! Wait! There it goes. The magnesium, the bubbles forming on the magnesium lift the magnesium right up the tube, and sometimes the reaction drops away so quickly that the magnesium sticks to the wall of the gas collecting tube. After I took the apparatus apart, let's take a closer look and find that piece of magnesium. There it is, stuck to the wall gas collecting tube after it was lifted up due to the buoyancy of the bubbles.